In this video, we're going to look at exercise 8.3, problem number 2, and we are discussing all the exercises from chapter number 8, which is Introduction to Trigonometry. Okay, so let's read what the problem number 2 says. It says, show that tan 48 multiplied by tan 23 multiplied by tan 42 multiplied by tan 67 is equal to 1. So we have to show that this left hand side is equal to right hand side. Now, if you focus on this problem that is given to us, let's focus for time being, let's focus on the numbers. Let's ignore this tan or whatever the trigonometry ratio is, and let's focus on these numbers 48, 23, 42, 67. Now, if you can observe closely, 48 and 42, their addition is equal to 90. 48 plus 42 is equal to 90. And similarly, 23 and 67, okay, their addition is equal to 90. So you can see that there are two numbers 48 and 42 where the addition is equal to 90, and again there are two numbers 23 and 67 where the addition is also equal to 90. So since we have numbers in our expression where the addition is equal to 90 degree, this is a hint where we should be going for the complementary angle property of trigonometric ratio. And what is exactly that? Just let's quickly note it down. We know that tan and cot are related to each other based on the complementary angle property. So tan of 90 minus some angle, let's say A, will be equal to cot of A. And conversely, cot, and you can even write tan here. So cot of, let's say 90 minus B is equal to tan of B. Okay, so this is the complementary angle between the trigonometric ratios tan and cot. Now, since these two are summation is equal to 90 degree, I am going to pick out just tan 48 and write it in the terms of cot. Okay, I am going to write tan 48 in terms of cot. So basically tan of 48 will be cot of 90 minus 48. So okay, let's go for this. Let me, okay, so tan of 48, okay, let me try to move this down. Yes, now tan of 48 will be equal to cot of 90 minus 48, okay, and that is equal to cot of, what is 90 minus 48? That is equal to 42, okay, and now again cot of 42 is equal to 1 upon tan of 42. Okay, this is a basic definition of cot of theta. Cot of theta is basically reciprocal of tan of theta. So cot of 42 is now equal to 1 upon tan of 42. So tan of, in fact, tan of 48 is now equal to 1 upon tan by 42. So I'm going to make this substitution. Let me use a line here. Let me draw a line here. Let me also draw a line here. Okay. So substituting this value in the given equation, we are going to get, so I'm going to write 1 upon, oops, I'm going to write 1 upon tan of 42, okay, in place of this. So in place of this, tan of 48. Tan of 48 is 1 upon tan by 42, and rest of the things will be same. So that is, and then into tan of 23 into tan of 42, okay, and into tan of 67. Okay, so this in fact is my left hand side. Let me zoom in right here. This is my left hand side of the equation. Left hand side of the equation. Okay. Now, very clearly we can again use a highlighter to make that point. This term, sorry, this term and this term are going to cancel each other out. Okay, and what we are going to get is, again, left hand side will be just be equal to tan of 23 into tan of 67. This is my left hand side. Now let's continue. Tan of 67 can be written as cot of 90 minus 23 into, this will be tan of 67 as it is. Okay, as we saw here itself, that this 23 and this 67, their summation is equal to 90 degree. So I'm going to convert this tan 23, okay, in cot using this property. So let's continue with our left hand side expansion, and that is equal to, yes, that is equal to cot of 90 minus 23 is 67. So cot of 67 into, we have got tan of 67. But once again, cot of 67 can be written as reciprocal of tan of 67. This is the basic definition of cot into tan of 67. And once again, they are going to cancel each other out and we are going to get 1. And this 1 is nothing but our right hand side of the equation. So we started with this left hand side of our equation with this whole big expression, and we solve, and we got 1, which is right hand side of the equation, which is exactly what the question is asking us to. So thus proved, okay, in fact we can write here, hence proved, hence proved, okay, that this expression is equal to 1. So let me use the eraser to get rid of this markings. Yes, okay. So thus we have proved that this entire expression is equal to 1. So this was our problem number 1 from question number 2. Now we have problem number 2 as well, which we have to okay. Okay, so I need to erase this whole thing to remove the problem number 2. Yes. So now let's zoom in a bit, and we have problem number 2 here. Delete. Okay. So once again we have to show that cos 38 into cos 52 minus sin 38 into sin 52 is equal to 0. So once again we will start with LHS, left hand side, and see if this equation, this expression evaluates to right hand side, which is equal to 0. Now once again the key observation, or the first observation that you should make is, we have 38 and we have 52. 38 plus 52 is equal to 90 degree. Okay, same goes here, 38 plus 52 is equal to 90 degree. So that is the biggest hint, and that is a very straightforward hint, that we should use the complementary angle property of the trigonometric ratios. Now the trigonometric ratios that are mentioned here in this expression are sine and cos, which are related by the trigonometric property of sine of 90 minus a is equal to cos of a, and similarly cos of 90 minus a is equal to sine of a. Okay, this is how sine and cos are related with each other through the through the complementary angle property. Okay, so now what I'm going to do, I'm going to focus on this first term, cos 38 into cos 52, and convert them into sine. And once I convert this expression into sine, then I think that minus this will be equal to 0. Okay, so let's try to focus on that. So I'm going to just write here, consider cos 38 multiplied by cos 52, and let's try to focus on this itself. Okay, so let's convert them into sine. So that will be equal to sine of 90 minus 38 into sine of 90 minus 52. Okay, and that is equal to sine of 90 minus 38 is 52 into 90 minus 52 is 38. So this term cos 38 into cos 52 has in fact got evaluated to sine 38 into sine 52. I mean, I can just rearrange this term, and I can just write sine 38 into sine of 52. Okay, so multiplication of a into b is equal to b into a, doesn't matter. So cos 38 into cos 52 is equal to sine 38 into sine 52. Now let's substitute this over here. So okay, let's try to get rid of these, and now I'm going to do this substitution for this term. Okay, and so as you can see, cos 38 cos 52 is equal to sine 38 into sine 52. So if you substitute that here, it is just going to be equal to sine 38, sorry, sine 38 into sine 52 minus sine 38 into sine 52, and that obviously will be equal to 0 because those are the same terms. So thus again, once again, using the complementary angle property, we have proved that this is equal to 0.